Okay, so I think we should probably start now. It's already 10:10, and hopefully more people will join in as the time progresses. So, very good morning to all. My name is Architect Tushar Mandal, and I'm a teaching faculty at the Periyar School of Architecture. I welcome you all to the 16th webinar in the Every Friday webinar series, a platform for young minds to express their ideas. Today's webinar will be discussing H-BIM and will be presented by architect Adityan G. Bharati. So before introducing the speaker for today, I would like to introduce and honor architect Premendra Raj Mehta, who is the mentor of the Periyar School of Architecture along with his partner. He is also the former president of the Council of Architecture. I request, sir, if we could just say a few words and motivate us for today.
Yeah, good morning, everyone. Adityan in particular, very warm welcome. And this is a very interesting thought we had almost 4 or 5 months ago that we should initiate a series of discussions on new ideas in the young minds. And Tushar has been a host of this. And I'm very pleased to share with you that we have had almost 15 such seminars, and some of the issues which have been brought out have been shared with the respective government agencies and some of the institutions. The idea is that if we have a new idea and if it could make a difference for our future, we should pursue. So Periyar at its end does two things. One is take it up with the government if it is necessary, and share it with others if it needs to be spread. So these are the two things we are committed to for spread of new ideas. And this series is to inculcate a habit in confidence in young minds that if they have an idea, I think it is worth exploring. So we would extend all possible support, whatever little we can do. But we want you and your friends and your colleagues to come forward, share their thought, and if necessary, pursue it by way of a follow-up course or a follow-up discussion. And Periyar would be very happy to host this. So a very warm welcome once again to all the participants and the speaker for the day. And wish you a very, very enjoyable discussion. Thank you.
Thank you so much, sir. So now I will introduce the speaker for today's webinar, architect Adityan G. Bharati. I request him if we could just switch on your camera, Adityan.
Good morning.
Yeah. So Adityan is an architect who has primarily worked in the field of heritage conservation for over 3 years under the guidance of renowned conservation architect Abha Narayan Lambu. He has previously been involved and responsible for project management for key heritage sites such as the Chandigarh Capital Complex and the Crawford Market in Mumbai. He has also largely been involved in the preparation of UNESCO World Heritage nomination dossiers and management plans for sites such as the Mughal Gardens of Kashmir and Shantiniketan, both of which have been official entries by the State Party of India in 2021 and 22 respectively. Currently, he is based in Helsinki, Finland, where he is completing his double masters and as an Erasmus Plus scholar. Today, he will be talking about using Scan to BIM for heritage conservation. I request Adityan if you could now begin your presentation.
Yeah, good morning, everybody. Thank you so much for having me here. Especially thanks goes out to my good friend Tushar for inviting me for this talk. So I'll share my screen now. Let's get on with the presentation. And I hope you guys can see my screen at this point.
Yes, it's visible.
Okay. So like Tushar gave you a brief introduction, what we'll be talking about today is about laser-assisted scanning technology for H-BIM. H-BIM standing for heritage-related building information modeling. So I'm sure everybody knows what BIM is. It's been going around. It's changed our AEC industry significantly over the past 20 years or so, and it definitely is how the industry is moving forward as we speak. In the field of heritage conservation, though, may be a bit more prominent out here in the West, but not as popular as it is for heritage conservation right now, in particular when it comes to integrating it with building information modeling. So we'll be going through why, how it is advantageous and how it helps in the entire process. I've worked in the industry for about 3 years, and unfortunately, not using these methods. So I definitely realize how where this helps and how it would have definitely assisted in making the processes easier. So let's just start with the basic. Let's first see what laser scanning is, as the name suggests, and I'm pretty sure a lot of you already know that it's a technology where we use these very, very powerful machines that emit lasers at a very high rate. And the time that is taken for the laser to exit the machine, hit a surface, and reflect back and get received by the machine, that time is in a way translated into distance by the machine. How the location and the distance of that particular point with respect to the origin axis, the XYZ origin axis of where the machine is placed, and it triangulates that position. And with that data, the machine is able to, in a way, give us this. It's called a point cloud, where the machine will be taking in information from millions and millions of points that it gets the position relative to the position of the machine. And that point cloud is then used by us using other building information modeling software and other processing software to generate what we could call a building information model. So laser scanning, like I just mentioned, it's not specifically restricted to heritage conservation. I mean, it's very widely used for a lot of purposes, including things outside the construction and architecture industry. But today we'll be looking at it from the perspective of, well, heritage conservation. So why it's important here, or in a way why building information modeling is important when it comes to heritage conservation, is that I mean, I do agree that, of course, a new built sort of projects, greenfield projects, of course, have their own sets of challenges. But when it comes to heritage conservation, there's a totally different set of challenges that are often that you can't predict, you can't be prepared for, because it's just very complex, because you have the documentation of the existing structure. You need to do an in-depth analysis of its conditions, its issues. There'll be a wide range of stakeholders involved. Usually, heritage projects are managed by the state, so there'll be a lot of stakeholders, a lot of complications in that process also. And even when you do make the conservation plan, you need to be very, very careful of how you want to keep the authenticity of the historic fabric. And the traditional method to go through all these processes is, well, manual. The way we do it, you do manual documentation, you send a team out on site, they make measured drawings, then you convert the drawings to digital drawings, and then you do your design over that, and so forth and so forth. But this is very, very time consuming. So the main advantage of making a building information model for an as-built structure like a heritage monument is that you save a lot of time at the cost of maybe a higher capital investment at the beginning, but it brings down the cost later on, because you save a lot of time, and it assists all the stakeholders in the project as well. So now, why scan to BIM? Why use laser scanning and integrate it with BIM in the case of heritage conservation? So if you look at the image at the right, it is a scan to BIM project done by a firm in India. So essentially, I don't know if some of the people here have been involved in heritage documentation or even the LIK trophy, from NASA during their studies or something. So I remember when I did that with no idea about heritage conservation, how to do documentation, and when you had a ornamented column like this with so much detailing in from the capital to the beam, what you essentially did was take as flat a photo as you could, so that it is in a 2-point perspective. You measure probably one distance, maybe between from the floor to the beam bottom, and then you just use that reference. You scale it on AutoCAD, and then you just trace it over it, which is of course one way to do it. But in that process, obviously, you lose a lot of detailing because it is very, very detailed. And of course, all the measurements won't be accurate. And all the little inaccuracies, these are heritage buildings. So these would be, hundreds to thousands of years old. So it won't be perfect. The geometry won't be perfect. So if you just take a photo and you trace over it, you of course won't be getting the actual as-built geometry that you have on site. So, even though traditional documentation like that is easier to do and cheaper to do, it is a lot more time consuming and, like I mentioned, a lot more inaccurate, which is why laser scanning is a different method that we can use, because it's fast, it's reliable, and it's very accurate, up to 1 mm to 2 mm inaccuracies maximum, or maybe not even that much in the case. It depends on what resolution you use. We'll go towards that just now. So now I have this little video, two videos actually, which goes through 2 stages that we're talking about. The first stage will be how we use the laser scanning to get the data from the site, and the second stage is how we use the data that we have acquired to generate our heritage building information model, and then further generate whatever documentation, drawings, or visualizations, or whatever we need. So let's go through this now. There is no audio, so I'll be running you through this process. So this one is, what exactly is scan to BIM? Okay, so we'll be going through what scan to BIM is through this example of this company doing the process in this church, which is the St. James Church in London. So, in theory, the scanning process can be done by just one person. So instead of being 10, 15, 20 people on site measuring different things, this entire thing can be done by just one person with the right equipment. But of course, the number can change. It depends on the site, depends on the outcome. Project managers do risk assessments. So you put a tripod, you put this laser scanner on top of it. In this case, it's the Trimble TX8, if I'm not wrong, and it's very portable and weighs around maybe 10 kilograms or something. So what happens is that there's this very high-powered laser that spins around at a very high pace, and then it hits the various objects and then gathers their position relative to the scanner. And these are the different points, so point 1, point 2, point 3, as you can see here. And then when several of these points are collected, they begin to build a highly accurate 3-dimensional digital picture of this space on the site, like these millions and millions of points. So a large collection of these points, like I mentioned before, is known as a point cloud. And I mean, this might sound obvious, but the more points you collect, the greater the accuracy of the scan. So this is what we call the resolution of the scan. So the scanner automatically rotates like this. So you get it in like 360 degrees vertically as well as horizontally. And in this case, the Trimble TX8 has range to up to 340 meters. You can place it in one corner of the room and pretty much get everything. So, the given idea of the kind of data that is collected during the typical 3D laser scan, the TX8 collects almost 1 million unique points per second. That means in a 5-minute scan, you have about 300 million points in a 5-minute scan. So it also has a camera with it. So while it's gathering the distance of the points, it's also gathering photographic images, which is called photogrammetry. So when you fuse both, you sort of get a three-dimensional picture along with all the RGB colors and textures. So I mean, yeah, so this is how it captures the thing. And then the one issue is, of course, when you place the camera at one point, some things, some areas you might not get the data. For example, if there's a column, you won't get the points behind the column. So you obviously need to place the scanner in 2-3 different positions to finally get all the required data for the space. And then later on, whoever's processing the data on their computer can just take the data received by the camera in a simple USB drive, plug it into their system, use Navisworks or ArchiCAD and softwares like that to gather the data, if you can see here. So this is not a 3D model. It's just millions and millions of tiny points clubbed together to sort of seem like a 3D model. But this is good enough because you can still analyze this data. This data is in a three-dimensional space. So aspects such as the X, Y, Z axis and distances are all still applicable here. So you can actually measure, for example, I think they show it in the video right now. You can example distance between two particular points. And of course, yeah, as it's visible here. And of course, you can use this model further, someone who's experienced with the software, to actually generate a proper 3D BIM model. So yeah, so moving on. So now we move on to how somebody can use the point cloud data generated to make a BIM model and further generate drawings from this. This is a firm here in Slovenia. The language was in Slavic, but I've translated it to English for you guys. So this is just an example. So if you have a small, medieval chapel like this, this is how the point cloud information would look like, just millions of points. Then somebody will have to process that and make a digital trace over it to make a digital model without a texture. Now, with using the camera in the scanner, you also have the photogrammetry that has been generated. So you can overlap both. So now you get sort of a realistic looking textured model. In a larger scale, for example, in the case of this palace, once you've combined the 3D geometry on a BIM software and the photogrammetry to get the textures, you ultimately have a pretty well-rounded building model. So now somebody needs to generate the outputs from it, such as the roof plan, for example. So now here, at least right now, I mean, there are powerful softwares out there which can trace the geometry on their own, but it's usually not recommended. Here we resort again to how we do it is just use AutoCAD again. But the difference is that instead of using a flat photo or just assuming dimensions or copy pasting the same column in a colonnade 10 times, you actually have the actual geometry and the actual distances on site presently, which you can trace over, which results in a much more accurate as-built model and as-built drawings. So as you can see, they've generated all the required documentation drawings from the 3D model here, including the roof plan, the sections, the floor plans, and in the case of making a conservation proposal, for example, for facade restoration, here with photogrammetry, you have the overlapped 3D model. You can trace the documentation drawing over it. Then, of course, once you have the documentation drawing, you can make the proposal drawings. And BIM software often have visualization engines, so you can also have create renders like these. So just to run over the process once more, this is essentially the methodology that is being used in this entire process, which starts with the classification of the considered elements, establishing the level of detail that is required, the actual scanning process, then point cloud data processing, the BIM model generation, and the analysis. So instead of explaining each of these processes individually, what I'll do is go through a case study later on, and we can go through each of these processes, how it's been used in that particular case study, so that it's more hands-on. But before we get to that, let's just go through the advantages and disadvantages of this process. The advantages, like from all my explanation, it must have been pretty clear that it's extremely fast. You get almost 1 million points that can be processed every second, and it has very, very high geometric accuracy. And like I mentioned, every object if you go to a building in Fort in Mumbai, or if you even go to the Mehrauli complex, and if you have a colonnade, every column is going to be different. Of course, they look the same, but if you're making an as-built model and an as-built drawing, and if it's going to be used by quantity surveyors to, for example, replaster it or something like that in the conservation process, you can't just say, oh, every column is just the same. Let's just take the quantity of the surface area of one column and multiply it by 100. If it's actually not that, if that isn't the case. Then the advantage is there's multiple formats for output. You're working digitally. So once you have the point cloud data, it can be processed into 3 or 4 different kinds of software. They can further be exported into whatever you need. If you're not comfortable with one BIM software, the IFC file can be imported into ArchiCAD, Navisworks, Revit, whatever you desire. And digitization of traditional documents. Yeah, often in a lot of heritage projects, you do find archival drawings that could be used. But again, these would be drawings that were drawn many, many, many years ago. So again, a lot of mistake that we often do, even professionally in the field, is that assume that, oh, let's just digitize the archival drawing that is available at first, so that we have a base, and then we can improve on it later on. But then due to time constraints and things like that, often it doesn't work. And in a lot of cases, especially in my experience, it isn't the same. Maybe the archival drawing was drawn and then they were actually building it, and they didn't actually build it the same way. So they're not often reliable. But in this process, you do get a digitized version of all these drawings through your scanning process, which can be used for years and years. Throughout the remaining life cycle of the building, they can be reliably used. Now, the disadvantages, well, it's expensive. The initial capital cost is a lot. You need the capital cost of the laser scanner, and then the person who operates it, and then the people who can process this data into a BIM model. Till that stage, it's very expensive. But once you have the BIM model, it makes the rest of the process extremely easy, because anybody, including your structural engineer, your architect, your MEP guy, even your facility manager, or even your client, can use the BIM model for a reference. And the other disadvantage is that the process might result in more data than it is actually required, because we're collecting so much data. You often end up with more data than is actually required for the purpose, which is why in the methodology, one of the initial processes is actually deciding what the level of detail needs to be, so that you don't collect more data than what is required, and this saves a lot of time. The third disadvantage is long processing times. Creating from the point cloud to the BIM model is sort of a long process in terms of computing time, not like human time. And if you have a very ornamental, intricate, features on any heritage property, the regular geometry and the objects that are the 3D objects that are eventually created are what we call high poly objects, which is high polygonal. So it has a lot of polygonal surfaces. And this would require really high-end computing systems. So you can't do it on your run-of-the-mill laptop or desktop computer. You might actually need very powerful computer systems for that. Okay, so now to the case study that I was mentioning. This is of the Riga Castle Convent. Riga is this little capital town of this very little Baltic country here nearby, very near to Helsinki here, which is Latvia. I don't blame anybody if they don't know exactly where it is. I mean, I did not know until I got involved, and I was roped in by somebody in the university to look into this case study. But what we're going to talk about is this is the Royal Palace in the capital city of Latvia. So the client specifically, and this is something that we in the conservation industry, even in India, need to be prepared for, is that since we are moving towards a digitized environment in the architecture industry, and in India, it's not gained traction, but in such countries, the clients, even before the project starts, make it a mandate that there needs to be an as-built BIM model that needs to exist. In a lot of countries, even here in Finland, right now, for a new built project, it is standard practice to work with BIM. Maybe not as much with heritage, but in new buildings, definitely. That's not the case in India in a lot of cases either. But here, in this case, the client mandated that they do need a heritage, a BIM model for the castle, and the strategy adopted by the architects were to appoint this agency that would scan the entire complex, because it was the brief was very complicated and they didn't want to leave any stone unturned, so they wanted to do the BIM model through laser scanning. A little bit of history. The castle was built in the 1330s, and then there was a lot of damage over time. If you know this, Baltic states neighbor Russia during the World War, there was a lot of back and forth between the Soviet Union and the Axis powers, and there was a lot of damage. So there were a lot of people who ruled Latvia over this time. So it was reconstructed many times during when the Swedes were here, the Germans, the Soviet Russians, and then eventually the Latvians. And since 1922 was the last renovation, and then it became the residence of the president of Latvia. So it's the presidential palace now, and it does have a lot of museums in it, and there is a huge chapel in the complex as well. So the brief given to the architects for the renovation process was that they need to generate an as-built model in a BIM software, and in this particular case, they were specifically asked to do it in Autodesk architecture for some reason, which even they were baffled about, because it's not exactly the definitive, powerful BIM software. But either way, then of course structural consolidation. There was a lot of areas where there was structural damage and issues, so that was a part of their brief. Then the chapel actually was a double-heighted space, but over time they had inserted a floor in between. They had inserted a slab in between for some reason, and they needed to remove that entire chapel floor to restore the entire height of the chapel. Then they needed to design the new museum that was to be in the palace, and they wanted additional public spaces in the attic. So how did they go through this? Okay, so now we go back to the methodology that I was mentioning. So at first, you go through the classification of the considered elements. So what this means is that deciding what all spaces need to be modeled. In this case, the client specified that the BIM model itself needs to be mainly only for the south chapel side, including all its floors, the basement, and the roof. So you have to identify all the different elements that need to be scanned. For example, the ribbed walls, the arches, colonnades, apart from the basic walls, ceilings, windows, doors, etc. And then in this case, what they did was that they took a small piece of before starting off the entire process, they took a small section, a sort of a test zone sample section, and they took that zone, and then they did the laser scanning there, and then they evaluated what various modeling techniques. So there are different softwares that you can use. Some are faster, some are more equipped to handle detailing like this, some are less equipped. So since this was a unique pilot project in this case in Latvia, so the agency tried different modeling techniques to actually find which one would be the best. So, this time took about a month just to do this little section that you see here in the photo, this tiny little section. But how it helped is that once they could do that particular research in the initial 1 month and they realized the best way to move forward, it made scanning the rest of the building much more easy. Then we come to establishing the required level of detail. Like I mentioned, you can get a geometric accuracy to up to a few millimeters to a few centimeters. So in this case, again, the client has established that the level of detail needs to be very, very high. So it needs to have a high level of geometric accuracy and information fullness. So the level of accuracy in this case, then they established that it would be up to 5 mm, 5 mm, and with a buffer for deviation from the point cloud for about 2 to 3 centimeters. That means when you're taking scans from different points, if there is a deviation of that much, that can be adjusted to be accurate. So this would allow very precise geometry to be measured and then integrated into the model. Now, some complex geometry. So in the basement area, there were a lot of these ribbed vaults, and in the attic area, of course, you have the pitched roof, pitched roof in timber. So in this case, when they did the initial scan, they went to the client and said that, hey, you want us to give you the BIM model in Autodesk architecture, but you see these are incredibly complex geometry, so we might not really be able to give it to you in like just line drawings. These need to be wire meshes. So these are it's like a crisscrossing mesh that generates 3D geometry. So when they did the initial scan for that section, they realized this limitation. So they could communicate it to the client, and then the client could approve of this so that they could stick to the wire mesh for complex geometry like this. Then the actual scanning process, like you saw in the video, nothing new there. You place the camera in different various points and you gather the information required. So in this case, 360-degree panoramas were captured, and interesting trivia, they hired some mountain climbers to climb onto the roof to get the scans at those areas as well. And then the point cloud data processing. So now you have the scan, so you have lots and lots of point clouds. So you need to process this data now. So there can be various software that this can be done on, like I mentioned earlier. So in this case, almost 70 gigabytes of data was gathered by the team. So they had to actually divide the entire structure into different levels, different floors, and do it one by one so that the data was manageable. Otherwise, it would have been too much. And using the camera in the machine, they also could generate a photogrammetric model like this, which with the actual textures and the actual condition of the site. Then the actual BIM model generation. So like I mentioned earlier, the BIM model and the IFC file that was to be given to the client had to be on AutoCAD architecture. So initially, the agency was not confident about using AutoCAD instead of, something more popular like Revit, for example. But, after some testing, they were able to find a workflow that would make the model possible. So teams were divided based on the levels, each floor, and then each was modeled separately on AutoCAD. And then all the several entities that were discovered to be, impossible or too time intensive to model, like I mentioned, the rib vaults and the pitched roof, they did that in Rhino using some plugins like Geomagic, etc. And then after they generated the geometry there, then they imported it into AutoCAD, and then they placed it on the model. So then quality control is also required. You can't just take the scan and then expect to sit in your studio and do the rest of the project like that. You need to do quality control. Machines often have issues. You might not get all the all the data that is required. So the quality control of the model was done by making multiple walkthroughs and then making sections in Navisworks and AutoCAD, and simultaneously, very important, there were constant site visits by the people to, maybe identify small cracks or, so small damages or details that might have been missed by the scanner. Sometimes that does happen, so you need to do that as well. And finally, the analysis that they did with the data that is gathered. So the first deliverable in this case for them was a report on the structural deviation. Structural deviation as in the walls are supposed to be straight, but over time they might be sagging or leaning by the historic walls. So they needed to figure out what the structural deviations would be, so that the structural engineers could make decisions about structural consolidation. So this analysis they could do in like 2 ways using this model. The first was the point cloud was just imported into Revit, and from the Revit they could make a lot of sections, and when they made us like you see here on the left, they could make a lot of sections, and then they could just see if the geometry is deviating from a vertical line. And the second one is kind of interesting. What they did is that they used the a point cloud to generate sort of a heat map. People who were into calculating building energy would be aware of this, but this is not exactly calculation of the heat levels at different surfaces of the building. They just use the similar palette to generate a heat map of how far each point is from this perfectly straight y-axis. So the farther it is from the y-axis, the more red it is, and the closer it is to the y-axis, the more blue it is. The more green it is. So in a way, you get a representation of which parts of the wall are actually leaning more away from the y-axis than the other. So that was the deviation analysis. And then ultimately they had a 3D model like this. Anybody can take that model from AutoCAD architecture, import it into SketchUp. I guess SketchUp is what's popular with students nowadays. So you can import it into SketchUp, analyze it there, and this model you can give it to the architects. They can use it to do the design coordination, make more precise drawings like I showed in the video earlier. And in the post-construction phase also, after the museum is designed, it can still be used for, facility management and maintenance and things like that. So here is a quick video. The actual firm that did do the design, they had a small sort of a walkthrough. So this is the actual castle. This is not the BIM model. This is the BIM model that was generated from the scans. So if you can see, I don't know if it's visible, maybe because of the resolution or something, but if you see the walls, it does have certain structural or surface. How do I say it? Like it's not even and things like that. So these are the kind of details that are usually missing when you document a structure like this manually and then just build a SketchUp model. For example, you would make the same column, you would copy it 10 times. But in this case, they were also able to show, for example, this wall was not historic. So after the documentation, they could figure out that it was not a historic wall. So now they're removing it and making way. And like even the staircases, how it was earlier, and fix that. This is some of the public spaces that they did. I want to show you the chapel in particular, because like I mentioned, they needed to remove one of the additional floors that was added to the chapel, which comes next, if I'm not wrong. Yes. So if you see, this was a non-historic floor that was added to the chapel. So after the scanning, they were able to remove it, and they were actually able to get the full double height space for the chapel. And yeah. So you can obviously, from the model that is generated, whatever visualization software that you prefer, V-Ray, Lumion, 3ds Max, whatever you need, you can generate walkthroughs and visualizations like this, like you would do anyway, right? So the The only difference here is that the model that you do generate is actually a highly accurate and highly time-saving model that can be used by all the stakeholders involved in the project at, till the end of the life cycle of the building. So finally, to conclude, just some points. So managing the building and its restoration using building information modeling is applicable to multiple heritage sites. And the owners and facility managers can use the laser scanning and the model itself to effectively plan restoration and preventive maintenance. So the owners can also benefit from the production of the quality. Then there are various digital documentation methods that are available to experts today, and almost all of them, if processed appropriately, can assist in creating these BIM models. And then the heritage BIM models significantly reduce the time for documentation, design, and analysis for the operations phase, even though the initial cost to undertake the survey might be high. It's an easy to replicate methodology which can be adopted for the documentation process, which can be standard practice in the industry. So essentially, heritage building information modeling is the future of architectural conservation, with a lot of countries mandating building information modeling for most of their projects. It's not far that it comes to heritage conservation and architectural conservation as well. So experts, if they haven't, they should start exploring and embracing this to sort of future-proof themselves for the next 50 years or so. So yes, that concludes my presentation.
Okay, so thank you, Adityan, for the talk. I think it was quite intriguing and very elaborate. So participants can now ask questions. You can put your question in the chat, or you could also just simply unmute yourself and ask the question if you want. So if we would like open the floor for participants to ask if there's a question. Yeah. So if there's a question, please go ahead. Okay, so let's in the meantime, let me start with a question for Adityan.
Sure.
Like for example, you talked about the management of a point cloud, right? So a point cloud that is being generated, let's say through this sort of so I am assuming that it's a LiDAR sensor. Okay, so wait, just a second, sorry. I think Mehta said you can unmute yourself, I think, because...
No, Tushar, you go ahead, ask your question. I'll be the next.
All right, all right. Okay. So yeah, so I think you talked about getting a point cloud from a LiDAR. I am assuming it's a LiDAR sensor that is doing the job of the laser. So is there, let's say, is there another methodology that can do the same job? Because for example, if just to give you an example, I have worked on a sort of a very smaller scale of a similar case where, but that documentation was done using simple photographs. So what we did was we clicked photographs of the object from all sides, and then we took it to a different software and did the same job. But my question to you is that what is the feasibility of that sort of an operation when compared to, let's say, a laser pointer?
See, it actually comes down to the actual accuracy that you desire itself. I mean, you could do that. You could take different photographs and stitch them together and do a similar thing as well. But the thing here is, okay, so first thing, LiDAR is sort of a different technology. You could say 3D LiDAR came, the LiDAR technology came after this particular 3D scanning technology that I mentioned. It's mostly the same. It's just that LiDAR probably does a bit more. The software integration with the LiDAR scanners is a bit more developed, so it's easier to generate the 3D geometry instead of having softwares where you actually need to trace the building geometry over the point cloud. In the case of the LiDAR, the software integration is such that the geometry is generated much more automatically by the software, and then you just need to do a quality control check over it. So that's where how LiDAR is a bit more advanced, but it's way out of my expertise in terms of how it is used. So I still need to study that. And the second question of if you can use, if you use a simple laser pointer to do the measurements and things like that, of course, that can be used. But then again, like I mentioned, it just comes down to the geometric accuracy that you require for the projects. In some cases, for example, when I was working in the Capitol complex in Chandigarh, we did use these laser scanning methodologies to do the scanning, but those are office buildings. For example, if you go to the Secretariat or even the High Court, the Chandigarh High Court, for example, and if you go into a courtroom, it is a historic courtroom. It is designed by Corbusier. From the furniture to the ceiling to the tapestry behind the Chief Justice there, but it is a courtroom after all, and it's an Indian courtroom. So it's a mess. It's usually a mess. There's a lot of archival files lying around, this, that, and when you're doing a manual documentation in a space like that, even if it's using a simple laser pointer and photographs, there is a lot of data that will be lost. And when you're integrating the data as well, having to manually do it by figuring out, okay, this is where I was standing, and this is the photo from there. This is where I was standing. This is the photo from there. And then actually generating the 3D geometry out of that would be possible, but of course, it's much more complicated and it needs a lot of thinking power. When you have a laser scanner, even if the room is messy, it plays it at 2 points, it gathers the data. In the software, you put the origin axis, the point of 000 for both the scans as the same point, and then it automatically just fuses both and gives you an accurate representation. So as the complexity of a space increases, manual methods start to become much weaker or much more inaccurate. So that's where laser scanning would make it much more accurate and fast. I hope that answers the question.
Yeah, thanks. So yeah, if any of the participants want to ask any question, then please feel free to unmute yourself and ask. Or you could also put your question in the chat box. I think we have a question in the chat.
I'm not sure about Humpy.
Prakriti Mehta asks.
Yeah. So she's asking if there's a similar scanning process while you're mapping historical settlements like the Humpy ruins specifically, while you needed terrestrial mapping in cities. Yes, you can do terrestrial mapping. There's a lot of other mapping techniques nowadays, including using things like drones, so that you get more aerial scans and urban level scans that can be done. And even in the case of Chandigarh at the Capitol complex, we did employ these surveyors who would do these really powerful cameras on drones to actually map the entire site from the top as well. Specifically in the case of Humpy ruins, I did work with Abha, and Abha did work on Humpy, although I wasn't working with her while she was doing the project. But from her standard workflow, I'm pretty sure that this was not employed when they were making the management plan for Humpy. But the Indian firm that I did show you earlier, the little drawing that they did, it's a firm called Dharatal. They have employed this sort of an approach in this in another temple city, or in Rajnagar and Orcha. There they have a lot of heritage documentation that they've tried to use this process. So if you're more interested, they have it on their website, on their portfolio. So the project is called Reconstruction of the Lost Gardens of Rajnagar and Orcha by Dharatal. There they have employed
I think we should probably put that in the chat.
Okay,
the name of the project and the firm.
Sure.
Yeah. Okay, so yeah, if there's another question, then I think we can take one last question based on the time. So yeah, if there's a question, then please.
Can I say something?
Yes, sir, please go ahead. Please go ahead.
Yeah,
sir.
first of all, let me compliment Adityan. Very informative presentation you have made. And I think our country needs this without getting into more detail. We need it simply. And I think these kind of processes are for the future and it needs to be attended. I just want to understand one thing. You repeatedly said it is a very expensive proposition to do this.
Mhm.
Why do you say that?
I mean, it's for example, to document, just with an example, to document the High Court in Chandigarh, which is essentially 3 floors with about, maybe not a lot of rooms, maybe about 20 rooms, interior, exterior, to do a LiDAR scan, for example, was costing about 10% of the entire budget that was allocated by the Chandigarh administration for the entire project.
No, I have still not understood. In absolute terms, what is the cost of equipment? Training the people is a different issue. Human resources always, whichever be the technology you need to have them. But is it the cost of equipment which is so high that you are repeatedly saying it is expensive?
No.
You see, budget may be, budget may be wrong. You see, that time the budget may be wrong. So let's not get carried away with that budget. But what is it? Because you see, this is something which I prima facie I feel that okay, we should be doing it. So I want to understand, why do you say it is expensive? Is it the cost of equipment which is worrying you? Or
no,
would worry
it's not the cost of equipment. It's the cost of the service that is offered by the surveyors at the moment.
So it doesn't matter. When you so supposing I say IT is very expensive. Does it mean anything? You see, you ought to be doing it, and human resource will come along with it. So
fair enough. It's only, I mean, it's only with respect to, the traditional documentation methods. So a lot of conservation firms, or at least in my case where I worked, when you do propose something like, oh, let's do laser scanning instead of sending 20 students to site to manually document the thing, it comes down to a cost, and they're like, oh no, let's just send 20 students to site to do the documentation.
Okay, got your point. You see, whenever there is a technological shift, you see, this would be a barrier. But let me say, we would like to discuss it in more detail at the school, whatever proposition you have in mind, and understand it a little better, and pursue it with those who would need this to apply for maintaining our heritage for our future generations. So thank you very much for your contribution.
Thank you.
Okay, thank you so much, sir, and thank you, Adityan. I think with this we will bring this seems to... Okay, so with this we'll bring the webinar to a close. Before closing, I would like to inform everyone about the Every Friday webinar series that is being organized by the Peria School of Architecture. The webinars are a platform for young professionals to express their ideas, and they are aimed at students and young architects. I would like to thank Adityan as well as our senior academicians, all the participants, for taking out time today and for the wonderful presentation that we got to see. Please have a good day. Thank you.